Hey guys, this morning we're going to talk about multi-step equations and multi-step equations that that have variables on both sides, and also some special cases about multi-step equations. So where we're going to start in our notes, not there. That's coming up, but not yet. So just to remind you, yesterday we were here. And when we were here yesterday, we did not have any equations where we actually had to get variables on the same side, right? And you should already have a bunch of examples that you probably need at paper to get all my examples down from yesterday. So we're going to have some more examples, but we're not going to put them there. We're going to skip over these special cases and we'll come back to that in a few. This is a very long example, as you can see, a very long example that goes through all the steps, right? You have to use every one of those steps for this. So in this case, we distribute so we took the 8 times the x, the 8 times the 1. We had to distribute 3 different places. Then we had to combine like terms that were already on the same side. Both of those two things would be considered as simplifying each side of the equation. Now where things are different, this has x's on both sides. And yes, they're like terms, but they're on opposite sides of the equal sign. So I can't just add them together. I have to move one of them from one side of the equation to the other. So I've added 7x to get rid of this x that is on currently starting out on the right. So when I add that 7x, then that cancels out. Now we have 12x minus 4 is 14. Now it should look familiar because now we're just at a two-step equation. I'm going to add 4 so that these 4's cancel out. And then I'm going to divide. Now, this problem, well, IXL likes to give you lots and lots of problems that have 2 negatives together. OdysseyWare liked to give people lots and lots of problems that didn't divide equally. So I tried to prepare my students for that because fractions and decimals are also real numbers, and we can get those as answers. So far, that's not been the case, and it's been a little bit of a reassurance when you get a whole number. But 18 over 12, 1.5, or 1.5 would be the same thing. So we're going to look at some step-by-step. I just wrote that one out and gave you the reasons out to the side. So we're going to look at some we're going to look step-by-step that we are going to be solving the problem, and it won't have quite that many steps, but more than yesterday. This is actually attempt number 3 to make the video this morning, so bear with me. So here we go. If I have parentheses, so I'm going to have some distributing to do. So 3x minus 5 is equal to 2 times x plus 7 minus 12. So first I want to simplify both sides of the equation. So I'm going to distribute 3 times x, 3x, 3 times negative 5, negative 15, 2 times x, 2x, 2 times 7, plus 14, and then we still have that negative 12. So now before you start trying to do anything else, I would always advise that you completely simplify each side. So don't start trying to do, I'm going to do plus 12 or what, just combine like terms. Also, when you're on the same side, you're combining the like terms. You do not want to do plus 12 and plus 12 somewhere else. You want to do 14 and a negative 12, which makes plus 2. So now I have each side of the equation as simple as I can make it. The next thing I'm going to do is try to get those variables on the same side. And that's the part that's new today. So I typically like my variables on the left, just a creature of habit, doesn't really matter. But when I look at this, I'm going to try to get rid of variables that are on the right. So to get rid of a 2x, a positive 2x, I would need to subtract 2x. So that's what I'm going to do. I'm going to subtract 2x here. And remember, it's an equation. Whatever we do to one side, we must do to the other. You got it. So I'm taking 2x away from both sides. This is now gone. And then what we're left with here is x minus 15 is equal to 2. And then from there, of course, we would now be adding 15 to both sides to get rid of that minus 15. It won't let me change colors in the middle, so x would equal 17. So we do what we have to do to simplify each side of the equation, then get your variables on the same side, and then it's going to be, in this case, only a one-step equation, but sometimes a two-step. So let's try another one. Maybe. All right, here we go. So 5 times x, let's mix it up a little, plus 3 minus 2x equal to, say, x plus 2, let's see, 10, 15. We'll try that. Although there's not anything there that would have to be simplified, so that's okay. There's still variables on both sides. So distribute, there's 10x plus 15 minus 2x is equal to x plus 1. So now we're going to tidy things up on each side of the equation. The right side's just going to be chill for a while. On the left side, the 10x and the negative 2x can get together. So 10x minus 2x, 8x, plus 15 is equal to x plus 1. Now we want to get rid of that x that's on the right, so we're going to subtract x on both sides. That's going to leave me with 7x plus 15 is equal to 1. Now I'm at a two-step equation. Now that there's only one x, I want to get him by himself. So we're going to subtract 15. So 7x is equal to negative 14. Divide both sides by 7. And x is equal to negative 2. Again, we can always plug the number in to every place there is an x, and then we will see if the left side is equal to the right side. Okay, so we're going to switch over to IXL so you can see what some of those problems look like. So this is in J6, and I've probably kind of prepared you for the worst, but I'd rather you have some longer examples written down. So on this first one, there is nothing to simplify on both sides. Remember, you won't always have every step. Okay, you won't always have to do every step. In this lesson, you should expect you're going to have problems where there are variables on both sides, because that's kind of what it's called. So in this case, there is not anything for me to simplify. Both sides are already simplified. But I want to get rid of the y's that are on the right. So, and it honestly doesn't matter which, but especially since there's already a constant there. So to get rid of this negative 3y, I'm going to add 3y to both sides. Remember, still what you do to one side, you have to do to the other. So negative 2 and positive 3, just make that 1y, which we can just write y. And on the other side, the negative 3y and the y cancel out, and it's equal to negative 3. And if I would check it, negative 2 times negative 3 should be equal to negative 3 minus 3 times negative 3. Pardon me. And if I look at this, this is 6, and this is negative 3 plus 9, and negative 3 plus 9 is equal to 6. So the two sides are balanced. Notice when you check the equation, you're not looking for both sides to equal negative 3. You're looking for the left and the right side to be equal to the same thing. Pardon me. All right, so far so good, I hope. So negative 3 was our solution. I gotta turn that off before it'll let me do that. You can move your variables to either side. If there's a side that has only variables, then it may be easiest to move them to that side. It'll be one less step. So here we have negative 8 minus 9f is equal to negative f. So I don't want to get everything on the same side. So I'm going to move these negative 9f. I'm going to move that. I'm going to get rid of it. So I'm going to get rid of it by adding 9f. Whatever I do to that side, I have to do to the other. Now we have negative 8 is equal to negative 1 plus 9 would be 8f. And then divide both sides by 8. You're always dividing by what's with the coefficient. So f would be negative 1. So let's bump it up a notch. Okay, so now we see we're going to have constants on both sides too. This one's going to be pretty straightforward. 5g minus 10 is equal to 9g plus 10. So we're going to need to get those variables on the same side, and then it's going to be a two-step equation. And again, it does not matter which side you put them on, but you do not want to move everything to the same side. So if I want, I can get rid of these g's. If you move them the other way, you're going to get the same answer. Now, if you accidentally move everything to the same side, then you're not going to get the same answer. Your sign is going to be wrong. So if I get rid of the 5g, now I have negative 10 is equal to 4g plus 10. And then I'm trying to get that g by itself. So I would want to be getting rid of this 10 right here. I want to get rid of him. I'm kind of pointing that out because it's not as obvious, because I'm going to come down here and I'm going to write minus 10. I want you to know that I'm writing minus 10 because I'm trying to get rid of this plus 10. I'm not writing minus 10 because of the minus 10 that's above that. That's just coincidence. So then these are the ones that are canceling out. I know it's really tempting to try to cancel that out. And then negative 10 and negative 10 is negative 20. And then negative 20 is equal to the 4g. Now we're going to divide both sides by 4. And then we see that g would be negative 5. So negative 5 for g. Terrific. All right. So if there's only one variable, the problem is going to be shorter if you move, if there's only a variable on one side, sorry. Like here, the problem is going to be shorter for us to move the w's to the left. If you do move them to the right, then you're going to have a step where it says 0 equals 9 plus w. Should work out either way, but people tend to forget about that 0. More the same. More the same. I guess I was preparing you guys for the worst because these are not, they throw in a decimal here. So I got a decimal on this one. Let's make sure we work through one of those so you see it's not really a big deal. So I have 4.4s is equal to negative 3.2 plus 4s. So I want to get those s's on the same side. And since there's nothing else on the left side, I definitely want to be putting the variables over there, which means I want to get rid of this 4s that's on the right. So we're going to be subtracting 4s on both sides. And then that leaves us with 0.4 or just 0.4s. It's equal to negative 3.2. And then we divide. So that should look kind of familiar. It kind of looks like 4 and 32, right? Well, since they both have one decimal place, we can think of it just like that. And the signs are different, so it is negative 8. So when you put that in the calculator, this guy by himself is going to go in first, and the one with the variable is going in second if you're in doubt. So negative 8 is our solution. Oh my goodness, go away. Sorry. Not you, don't go away. All right, so this is just the same things you've done on other examples. They just put decimals in there. So really not such a big deal. Keep an eye on your positives and negatives. So the other topic that we are going to talk a little bit about today that was not on my original plan because I didn't know you guys would do so awesome yesterday, and most all of you got that I-6 done yesterday. So the other thing we're going to do, if you scroll back in your notes, or page back in your case, is we're going to look at some things about special cases, special things that happen in an equation. It doesn't happen often, but it can. So if I look at this problem, x plus 7 is equal to x plus 6. Make sure that I'm sharing what I think I'm sharing. Yes, all right, good. Be very bad otherwise. I would be trying to get my x's together, so I would subtract x on both sides to get rid of this x on the right, and that would cancel out, but dang, that cancels out too. And what I'm left with says 7 is equal to 6. Not in my world, right? So that's what I was kind of spelled out here below. If we try to get the variables on the same side, they both cancel out. What's left is not true. Okay, what's left is not true. What's left just isn't a true statement. And so this is not true, right? No, not true. And so when there is no solution, like this would be no solution. So I believe in IXL, they're going to call that, that's what they're going to say, that you would have no solution. There's also in set notation, that can be written as the empty set, and it just would look like the little set parentheses, special braces or brackets there with nothing inside, okay? So that means there's no solution, or it's also called the null set. But in IXL, pretty sure they use simple no solution. So that's one special case, when there's no number in the world that could possibly make this true. Another case is something like this next one. When I simplify both sides, 2 times x is of course 2x, and 2 times 5 is 10. And then, hey, hello, both sides look exactly the same, right? So you might notice before you even go any further, wait a minute, 2 times x plus 10 equals 2 times x plus 10. Well, duh, of course it does, right? Doesn't matter what number we use. If we multiply it by 2 and add 10, it's going to be equal to if we multiply it by 2 and add 10. If we try to continue to solve, if we don't notice that, what's going to happen? Well, the x's would again cancel out. So that would be gone. This guy'd also be gone because we would subtract 2x to try to get them together. Bam, gone, gone. And what's left? Now what's left is true. 10 does equal 10. So in a situation like that, now we are not, it's not that there's no solutions, it means there are infinite solutions. Okay, so you see what I have down there, infinite solutions. So that means like any real number. So there are infinite solutions. There are multiple numbers that make this true. Those kind of equations are called identities. Remember, like identity property? Maybe you remember, maybe you don't. Those kind of equations are an identity. You might see that without doing the whole process. For instance, when that said 2x plus 10 equals 2x plus 10, you should see that. Or if you see 2x plus 10 equals 10 plus 2x, well, yes, those two expressions are equal, so yeah, that's an identity. Now, getting 0 for the answer does not mean no solution. So, for instance, this next example, if I get my x's by itself, my x's on the same side, sorry, I would have x plus 5 equals 5. And when I subtract 5, I get x equals 0. 0 is a real number, all right? So that doesn't mean no solution. That is a real number. It's when the x's are completely gone, there's no x on either side, and the numbers you're left with are not true. That's when it's going to be no solution. And you are going to practice that in J7. So in IXL, and you should see that it came up in your recommendations today. Oh, sorry. Oh, J7 you already did, my bad. J8. J7 was the one you guys rocked out yesterday. So J8, it's just asking how many solutions does it have? So if I combine this, 9t minus 4t is 5t. So 5t equals 5t. When it looks exactly the same on both sides, that's when we're choosing infinitely many because it works for every number. 5q equals 5q plus 1. Is there any number that you could multiply by 5 and get the same thing if you multiply by 5 and add 1? Yeah, I didn't think so. If you tried to solve it, what's going to happen? 5q minus 5q would be 0, and 0 is not equal to 1. So that has no solution. So if you simplify both sides and you see that they're exactly the same, that's when it's infinitely many. So 1b take away 7b. Yep, negative 6b. Negative 6b equals negative 6b. Well, that's going to be true for every equation because I'm just saying it equals itself. So when it's true for everything, when the two sides, you can see the expressions are equal, that's when there are infinitely many solutions. So this says 8f minus 2 is equal to negative 2 plus 8f. And it's asking, is it an identity? Remember, identity means it has infinite solutions. So are those two things exactly the same? Well, the 8f is positive. The 8f on the right is positive. This is a negative 2. This is also a negative 2. That is an identity because they are really the same thing. Also, if you tried to get your f's together and subtracted 8f, you'd have negative 2 equals negative 2. It would be the same true statement with no variable. So far we've had a no solution and some infinite solutions. Here, if I try to get my b's on the same side, I would get like negative 1b. So if I would subtract the 4b on both sides, I would have negative 1b is equal to negative 8. So I still have b's. So this would be an equation I can solve. So b is equal to 8. There's one solution. Only one. 8 is the only number that's going to make that true. So when there's a different number of variables on both sides, you're going to have one solution. I didn't necessarily have to figure that out to be able to answer the question, by the way. If I know there's going to be one answer, like I could solve it, then that means there's one solution. They're not asking me for what the number is. So when I see there's 3s on one side and 2s on the other side, I know there's going to be one solution. There's only going to be one number that can make this true. So here, I'm going to need to simplify things first. So if I simplify, 2z and 7z make 9z. So I have a negative 1 and a 9z. And on the right, I also have a negative 1 and a 9z. So that is an identity. So remember, identities have infinite solutions. All right, they have infinite solutions, and that's when both sides equal the same, like the two expressions are equal. Different number of h's on each side is going to end up being one solution. So if you get the hang of that one, it can go pretty fast because you're not actually solving the equations. So here I see 9j on both sides, but negative 4 and negative 5 are not equal. So this is not an identity because those two sides are not equal. This one would be a no solution if they asked how many solutions. All right, so 80 is your goal. And if you want more practice, ask me and I can recommend some other lessons. But those are the two that I would like you to get to today is J6 and J8. I will also be getting in touch with each of you to have you do a little kind of a quiz where you're just I'm gonna give you an equation and you'll explain the steps to me. And if we can't find a time to meet, I will have you record that.